Hello everyone, myself Nilam Ghadage, Assistant Professor at Department of Basic Sciences, Chhatrapati Shivaji Maharaj University, Panvel. Welcome to all to this video lecture on Introduction to Ring. So let us discuss about the ring. So first of all, we will see what is binary operation and then we will start with ring. Okay. Binary operation means if we take any two elements from any set and we will apply the operation on that two elements and we will get next element as a output from that same set. So discuss about the ring. What is ring? So are there any non-empty set with respect to binary operation, that is addition and multiplication respectively. So the algebraic structure which say R and operation addition and multiplication is called ring if that set R satisfies the following properties. The first one is R with respect to operation addition is commutative group. That is the set R will satisfy the five properties. First one is closure property. That means if we take two elements from the set R and we will add these two elements, we will get the output and which is also belongs to that set R, and that is called the closure property. Next one is associativity. If we take three elements from set R and such that A plus B plus C is equal to A plus B plus C for all elements from the set R. Next property is identity element. Identity element means if we add that element in any element of the set R and we will get the same element as it. Means in this case 0 belongs to the set R such that A plus 0 is equal to 0 plus A and we will get the same element as it is, that is A, and which is also belong to the set R, and that's why 0 is called as identity element with respect to addition operation. Next, additive inverse means if we take element from set R and we will add with another element, then we will get identity element. Means that both elements are additive inverse of each other. Here A is additive inverse of minus A and minus B is additive inverse of A. Next is commutativity property. If we take two elements from the set R and then A plus B is equal to B plus A for all elements, for all A, B belongs to R and hence commutativity holds. Next, multiplicative properties. So first one is multiplication is associative and second one is distributive property of multiplication over addition. Associativity of multiplication is similar to the associativity of addition. Means if A, B and C are the elements of set R and such that A into B into C is equal to A into B into C for all A, B, C belongs to set R. That's why A is inverse of minus A and minus A is inverse of A. For example, 2 plus minus 2, and this 2 element which also belongs to that set 2Z, and we will get 0. That's why 2 is additive inverse of minus 2 and minus 2 is an additive inverse of 2. Fifth property is commutativity. Take two elements from the set of even integers, that is minus 4 and 2, and add these two elements minus 4 plus 2 and which is equal to minus 2, and also 2 plus minus 4 we will get minus 2, and that's why here addition is commutative, and therefore the set of even integers with operation addition is a commutative ring. So next, multiplicative properties. So first property is associativity. Take three elements from the set 2Z, that is minus 4, 2 and 0, and by the property of associativity, minus 4 into 2 into 0, we will get 0, and minus 2 into 2 into 0, we will get 0. So associate here, multiplication is associative. Second one is distributive law of multiplication over addition. Take minus 6, 4 and 2 from the set of even integers, and the left distribute by according to the left distributive law, we can write minus 6, 4 plus 2 is equal to minus 6 as it is, 4 plus 2 is 6, and we will get minus 36. Also, multiply by minus 6 with this bracket, then we will get minus 6 into 4 plus minus 6 into 2, we will get minus 36. Hence, left distributive law is also satisfied, and therefore the multiplication is distributive over addition. And third, we have to show that ring without unit. Suppose E is identical